Good morning, my name is Barak and today I will make the keyboard project from the Arduino starter kit. And then I will enhance it. I will go step by step with the basic project while pointing the mistakes that I have made and solved. After that I will explain how to make the keyboard more interesting. Let's start! We'll start the project the way it is in the book. Small keyboard, synthesizer, piezo and switches. You will need for this one 4 buttons, 1 piezo, 4 resistors, 220 ohm, 10k ohm, 1 mega ohm, electroline in, electroline ground, 4 orange connectors, 1 yellow connector, 1 purple connector, 1 long connector, mine is yellow. It could be that in your package you have different color connectors. And of course, the Arduino itself, plus USB cable and a computer. I decided to cram this project a bit on the breadbox that I would have some space for the next phase. I will imagine that if you got to project number 7 in the Arduino starter kit, you know more or less what you are doing, and this code wouldn't be surprising for you in any way. I will just go through it very quickly, but for the future, if you want me to be more detailed, leave a comment below and I will see to it that I will have more details. Let's start. We have a global array with 4 sounds of the piano. In the setup we open the serial monitor. In the loop we collect data from the Arduino and present it. It will be easier, like this. Then we get to the brain of the operation. If keyval equals 1023, play a tone on pin 8, note number 0. It means that it will be like the first note. It will take this number. Else if keyval is bigger than 900 but smaller than 1010, play note number 1. It's the second one. Else is no tone. If it doesn't appear on the list here, it will make no sound at all. If you take it away, let's comment it away, the notes will not stop. It will be the last note that was played. It might be good for something, you can use it later in some other project. And now let's see a few notes. You hear that the last note is shaky, the 1023. It means that it sometimes gives 1022. I would recommend take this line and make the same here, but with the range of 1020 to 1023. Let's see how it works. If this is your first encounter with 10 mega ohm and 1 mega ohm resistor, they look similar enough. So just pay attention what you're taking from the box. This might be that why your third button will not work. Make sure all the pluses and minuses are in the right place. It seems simple, but for beginners it's something to pay attention to. It is not 0 in the digital in, but A0 in the analog in. It is not print IN, but print LN. Go with the flow. Follow the electricity. Something might be missing or standing in the wrong place. Just change it. The last resistor should go to the ground. I still don't know why is that, but what it does, it cleans the signal. So if you have like strange inputs, that could be the reason why we are having them. So comment below in a clear way if you care about more tricky things. Level 2! In this part of the project I will add 2 potentiometers. One to control the first note and the second one to space the notes from one another. This is my golden box. I built it for occasion like this when I finish the project and I would like to tinker with the variables and change it just a bit to see what my project can do without losing space on my breadbox. What we have here is just a simple 5 potentiometers connected with electricity that is spread all around and the output. This is the electricity in, electricity out, and this is by color, more or less. Each one of them goes from 0 to 1023. It means 1024 degrees. That is how it looks like without the golden box. I'm connecting the gold box to the breadbox. That was the ground, electricity, first potentiometer, second potentiometer. Just to give some numbers to begin with, I gave the notes the same number that we had before, even though we are going to change them very soon. And I added a few values for the potentiometers. First, which pin it is. Second, what values we get from that pin. Third, the translation from that pin to numbers that we can work with. I have both of them
more or less the same. On the second one, there is also range float. It means that I will take whatever I mapped in the range amount and make it much more precise number, like 1.5, 1.122. In the setup, we'll start the serial monitor and we are ready to start with the looping. Keyval, as before, analog from A1. We'll get the start node values from the A1 pin. For the start amount, we will use map command. We'll get the values from the start pot val. Start amount is a map of the values we got before. It means that it will check values from 3 to 1020 and translate it to 200 up to 400. Range amount will be mapped from range pot val and will range from 3 to 1120 and they will be translated to 500 up to 3999, and then we'll translate it into a float number that will be from half up to almost 4. For the range float, we'll take the range amount and multiply it by 0.001. That will give us a number between half to almost 4. I chose here a number that is higher than what the potentiometer is giving to have like a bit less range. I'm not sure why I did it when I built this, but probably I had a good reason. If you think that I'm wrong, build something else or try do it yourself. This one is the same as in the beginning, but it will be more modular. First, it takes the number from the start amount. For the second node, he will take the first node, multiply it by 1.121, multiplied by range float. Range float will give us more musical or more diversity and more space between the notes. If you ask yourself why I chose 1.122, it's because the number at the top are spaced in that ratio. The next node will take the node before, node number 1, and do the same thing to it. Now let's go to the serial monitor. I gave a lot of information. I don't think that I gave all the information, but enough to have some indication of what's going on. First one is key value. Push the button. We are getting some number. After that we have the start pot val, and after that the range pot val. We have hard to distinguish the knobs from the other numbers, and after that we have the range float, and then we have the nodes with the little ASCII note sign. Here we have all the ifs. You see that I fixed it a bit, that it will be less shaky. Now let's see how it plays.
As you can see, this is the first note, and this one is the range between the nodes, and it makes quite nifty sound. For the last part I will add another piezo and connect Mary, that I will have another set of keyboard. So first, let's make another line of electricity of ground on the other side. Second, put 10k resistors that will go to the minus. Then white button. Now I will connect the breadbox to the Arduino. Connect the last piezo 8 to the 12 to digital in 12, and not forgetting electricity out. That is here, and now the piezo. You will see that it is different size. Maybe it will act differently. I added another potentiometer to analog in number A5 to have another ratio to play with. I don't know if it is really necessary, but now we have it. This is how it looks when it is a bit more organized. Now that everything is connected and look like a big mess, we can go to the code.
For the last part I added another potentiometer for another float, for the ratio between those numbers. Now it is 1.122, but I thought I could play with it. I'm not sure it is useful for anything, but this is just what I did. Also, because we have more buttons, I added switches. There is a new array with the switches that just says that they are off, nothing is being pressed at the beginning. Serial monitor as usual, and I'm also telling the pin mode that it's input and not output for the new buttons. The new potentiometer that is a bit more precise. As I said, maybe not useful at all. Here I'm telling the switches from which pin to read from. The brain of the note array. You can see that there is no more 1.22 but just a ratio float and the serial. I took the heart and the notes away. Maybe it was a bad mistake. Let's see how it works here. On the right you can see the key val. A bit left from that, the new 4 buttons. It is just 0 and 1, so I could just smoosh it all together. Here we have the notes 4, 3, 2 and 1. Ratio float, ratio amount. This is start amount. It's not important because actually it is like the first note, but I'm adding it here anyhow. Maybe it will be useful for something just because I'm getting the information from the potval. Last but not least, as before, the if statement and another very condensed if statement for the switches. If the first switch is equal high, it means it gets electricity. Do tone, pin 12 and the first note. Else if, you know the drill. If there is nothing else, do no tone, and that is all.
Okay, let's see how it sounds like. Okay, and now let's see. This is the same sounds, just different piezo. If you noticed, I cannot override. The minute I'm pushing one button, I cannot push another button. Take a few seconds to think I cannot do that, and I will explain in a second. The reason I cannot override or do some kind of a chord is because Arduino works in a line, in a loop, but just in a line. So the minute one button is pressed, it says like, I go to the button, I'm checking. Press, 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 and you will not go to check the other buttons, what is going on with them. And that's all. One.
Sounds like Game Boy music.
Do you want to play?
Is it a game?
No, it's just making
Sounds.
music.
It's just Flula music.
Yes, something like that. 1 second, let me do it again. Conclusion time. First, the Arduino is working in a linear way. I cannot play 2 notes at the same time, even if I have 2 piezo. My program just goes with the loop, so I need different technology, different something, more coding, and later we'll learn how to do that. Second, not all equipment is the same. I'm talking about the piezo. The big piezo sounds much better than the small one. The small one just sounds reasonable in the high-pitched noises. Third, I can use the potentiometer to check the range of my equipment, especially if my equipment is very good on a very limited range. And for next time, I would like to connect a proper speaker. I would like to learn how to record, and I would like to learn how to play what I recorded. I hope you enjoyed. If you have something to add, some info that you think that I've neglected, or you just took this project and did something completely different to add more stuff and made it cool in a different way, let me know in the comments below.